Good day, viewers. You are welcome. How to find the value of k in this nice algebraic equations? K to the power 3 equals 27 divided by 8. And let's see a solution from here. So given that k to the power 3 equals 27 divided by 8. So let's try to cross multiply first. By multiplying this with this, we have 8k to the power 3 equals 27. So by transferring 27 to this side, we have 8k to the power 3 minus 27 equals 0. And 8 can be written in exponent form. So the exponent form of 8 is 2 power 3 multiplied by k power 3 minus, and also 27 in exponent form is 3 power 3 equals 0. And let's consider this rule. Let's say we have a raised to power n multiplied by b raised to power n. So this is the same thing as ab to the power of n. And when we apply it to 2 to the power 3 multiplied by k to the power 3, we have 2k to the power of 3 minus 3 to the power of 3 equals 0. And let's recall from this very important identity. Let's say we have a cubed minus b cubed. So this equals a minus b multiplied by a squared plus ab plus b squared. So here is the identity we are going to be applying at this stage. So if we let our a to be 2k and our b to be 3, so we have to replace it in this so that we have 2k minus 3, this in bracket, multiplied by 2k raised to power 2 plus 2k multiplied by 3 plus 3 raised to power 2, and this equals 0. So if you have an expression of AB equals to 0, this is considered as A equals 0 and B equals 0. Then 2k minus 3 will be equals to 0. And this implies that when we make 2k the subject, we have 2k equals 3. Then we divide both sides by 2. So by dividing both sides by 2 from here, so 2 cancel 2, as we have our k equals 3 divided by 2. And here is our first real solution to this. And also, when we recall from the other part, which is 2k squared plus 2k multiplied by 3 plus 3 squared equals 0. So we realize that we are going to let 2 raised to power 2 and k raised to power 2. So 2 raised to power 2, that gives us 4. So here we have 4 multiplied by, and k is also raised to power of 2. Then 2 multiplied by 3, that is 6k plus, and 3 square is 3 times 3, that is 9, equals 0. We have a beautiful quadratic equation here, as we are going to solve it using quadratic formula. So here is what we are going to need. We need coefficient of k squared, which is a. I will consider it as 4. We have b here, which is 6, and we have c, which is equals 9. Then we are going to insert this in this quadratic formula, which is k equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. And let's start by inserting this formula, all these parameters in this formula. So here we have k equals minus 6 plus or minus the square root of 6 squared minus 4 multiplied by 9 divided by 2 multiplied by 4. So the next step we have k equals minus 6 plus or minus square root of, so 6 square is 36 minus, let's multiply this 4 by 6 only. We have 4 multiplied by 36 divided by 2 times 4, that is 8. And then if we factor out 36 from here, what we get is k equals minus 6 plus or minus the square root of 36 into bracket of, by dividing this one by 36 we have 1 minus, when we divide this one by 36, that is 4, and everything divided by 8. Then by separating this, we have k equals minus 6 plus or minus square root of 36 multiplied by square root of 1 minus 4, we have minus 3 divided by 8. But square root of 36 is a perfect square. We have k equals minus 6 plus or minus 6 multiplied by square root of, so for this minus 3 we can write it as minus 1 multiplied by 3 divided by 8. And this implies that we have minus 6 plus or minus 6. When we separate this, we have square root of minus 1 multiplied by square root of 3 divided by 8. And square root of minus 1 is an imaginary root, which is I. Then we consider this as k equals minus 6 plus or minus 6i root 3 divided by 8. And let's say we factor out 2 from here, because 2 can go in can cut 6, 6 and 8. So by doing that, we are going to have k equals 2 into bracket of minus 3 plus or minus 3i root 3 divided by 2 multiplied by 4. And 2 times 4, that is 8. So when this cancels this, we are going to have the value of k equals minus 3 plus or minus 3i square root of 3. And we consider this as the other two complex solutions that satisfy this problem. I hope you learned something. Thanks for watching. And if you are new here to this channel and you find this video very interesting, please like, share and subscribe. Bye bye.